Hi, this is Roger from Kanka Labs, and today we're gonna review and tear down this cheap eBay DDS function generator, which you can get for between $20 and $30 or euros from eBay, including postage. The story behind it is because I'm working not working, I'm present once in a month here at the local repair cafe. That's where normal folks come in with their broken electric or electronic devices, and we try to repair them. These repair cafes are quite popular in Europe. I don't know if they are also known in the US or outside of Europe. So anyway, I was searching for a portable and battery operated and small and lightweight function generator, and two things came up at eBay. One is an analog XR2206 based function generator for around $8, but it has not arrived here yet, so I will review the other one later. But the first one that arrived was this thing here, and you already can see here it has a 9-volt DC input, not with the standard barrel plug or barrel connector of 2.1 millimeter, but it's a smaller one. But well, that's not of great importance. What else can we see? We have two outputs. The main DDS output, where the amplitude and an offset can be controlled with two little potentiometers. First thing here that's a bit annoying is you don't have an AC coupled output. It would have been better either with a switch or anything else, or a third BNC connector to have an AC coupled, because you have to put the offset exactly at 0 just to have a symmetrical or DC coupled, if you have to input a DC coupled signal. The frequency goes from 1 Hz to 65 kilohertz, so that's enough for my purpose, because I only need the audio range for repairing audio or hi-fi gear. And what's called here the HS or high-speed output, there you get a square wave, but only with 4 settable frequencies, 1 megahertz, 2 megahertz, 4 and 8 megahertz. And you have this membrane keypad here of mediocre quality, but you cannot expect anything better for $20 or $30, and a 2-line standard LCD. Now let's turn this thing on. It stores the last set wave output and the last set frequency. The first thing that is a bit annoying is there is some jitter in the keypads, in the membrane push buttons, and so apparently they didn't debounce. They didn't put a software routine to debounce the membrane keys. So first thing that could have been fixed quite easily. Perhaps we can see it one or more times, the bouncing of the keys. A second thing that annoys me is you quite easily, or you quite often, mix up the on and off switch, because as you can see, the default value is that the output is off, and you always have to put it on, but not with the on-off switch. And next thing you see is the off function doesn't work correctly. So whatever you do, and sometimes the software even doesn't function anymore, as you can see. So I don't know what they have thought about that. can't understand that there is any difficulty to put a software reset. So next thing that's a bit annoying, you get a clean reset only by unplugging the power and then putting it in the on mode again. And what I just said, you quite often mix up the start stop and the on off, and you just have seen if you accidentally press the on off, the software goes out of bounds. And the next thing that's a bit annoying, you only can change frequency or the waveform type when the DDS is set to off. So also a bit annoying. I don't know why they use an interrupt pin here for the keypad. So already at this point the usability is not very good. Now let's see how we change the function type and the frequency. So with the up and down buttons you change the type of function of the output signal. Here you can see the so-called high-speed signal on the high-speed square wave output. You can set this, as I already told you, only at 4 different frequencies. So that's only usable for testing any digital circuits. Let's see what else we have. We have a white noise or random noise, which is in fact white noise. Then you can set the frequency steps. Next thing that is annoying, let's set it here, or let's leave it here at 100 Hertz. You can set this in steps of 10 from 1 Hertz to, what's the maximum, 10 kilohertz. That's the largest step. So let's leave this at 100 Hertz. Then the different kind of signals are an Ecg signal, a reverse sawtooth, a standard or positive sawtooth, a triangle wave, square wave, and of course a sine wave. And that's what's for me the most important. We will later take a look at how clean the sine wave is, because DDS function generators have the property that they can generate quite clean sine signals with a very low distortion if they are made up the right way in software and in hardware. So let's leave this at the sine wave. And now if you want to change the frequency, remember we have set 100 Hertz steps, so there's a little bit of acceleration done in software, but to reach the highest end or to do large jumps, there is no further continuous acceleration of the change of the frequency. So it takes quite a long time, depending on the step you set, in this case 100 Hertz, to change the frequency to the desired value. So also this could have been easily fixed in software by doing a continuously accelerating ramp when you press the push buttons left or right for a longer time. That was it for a first look and what it can do. And now let's take a look at how clean the sine signal is. Just looking up if I've forgotten something. The output range, that's also a little bit annoying. It's set to go from 0.5 volts peak to 14 volts peak. I think this is even not a logarithmic potentiometer. It would have been quite good, because if you do audio measurements, you often need very low signal amplitudes just to test an amplifier or something like that. So in the range of 50 millivolts or something. and you have to fiddle around really at the lowest end of the range to get useful low output voltages. So all in all, at this point, there are quite a lot of things concerning usability that I really don't like. And now let's see if at least the output shape and the distortion justifies the use of this DDS function generator. So here you can see the software that I usually work with when I'm doing audio stuff via the sound card of the PC or laptop. It's called Audiotester. It's a software from a German programmer. It's shareware. Here I have the paid version with full extent. So anyway, I'll give you the link down below. For me, because I'm working for nearly 10 years now with this software, it's I'm quite familiar with it. And so let's see. We know we have a 1 kilohertz output. Here you can see the marching waveform. I use the standard line input of the PC, and here we see the FFT. We see the relatively sharp 1 kilohertz main frequency, and then here we see the higher orders FFT lines, and well, that looks quite good. If we, for example, we have the main line nearly at the 0 dB level. If I could twiddle around a bit to get it at exactly, yeah, this should be it. Now I don't get it any nearer to 0 dBs. So anyway, let's take the that you get so many harmonics. That's because of the DDS principle of the frequency generation. But you can see here the first harmonics here that is visible at, well, it's not a harmonic, it's at 1.5 kilohertz, so that's also a ghost frequency from the DDS function generating principle. But it is already 80 dBs, or nearly 80 dBs below, or let's say 75 dBs below the main frequency, and even in the higher orders here, 5 kilohertz, 9 kilohertz, we are here always below minus 60 dB, and 60 dB below the main frequency means that you have less than 0.1% distortion for each of the higher lines. So 0.1% distortion is quite good even for doing distortion measurement or for adjusting amplifiers for minimum distortion. And usually with amplifiers, the second and third harmonics are most visible, and they are here around 80 dBs below the main frequency. So the quality of the output sine signal is very good. We just for fun change the function type to show you the other function. For example, the Ecg looks like a classical heartbeat. What else do we have? Always forget to set the output off to get the next signal. Now this is the noise, and here you can see a strange feature. The noise is relatively linear. It's a white noise, but it starts here to go down at around 6 kilohertz, and then it rises up again. So this is not a very good representation of white noise, at least for anything above 6 kilohertz. So let's see what else have we got. The Sawtooth Signal. Also, this one is not 100% clean, but just enough for doing some test work. And let's see, we still have the square wave. Let's see how clean this is. Well, also with a little bit of ringing. This could in principle also be from the ADC input of the sound card that I use, but I don't think so. So this is probably a good representation of the real square signal that is output, but good enough for doing test work. And anyway, I already said it, I was most interested in the sine wave, and last should be the triangle wave. Yeah, this one looks clean again. So all in all, the best thing about this little device is the pureness or the cleanliness of the sine signal. Anything else is really concerning the usability, is really, I wouldn't advise this thing, and I probably won't use it. And I'm eagerly waiting for the $7 analog XR2206 based kit arriving hopefully in the next 1 or 2 weeks. So now finally let's stop this here and take a look inside and see what we get, how they managed the hardware here. So I've already unscrewed it, and first of all let's take off the top cover, where you see the flat flex cable from the membrane, keypad, a standard 16:2 LCD with some little 2 pin headers. And well, what's quite nice is that they have printed all the component values and functions on the silk screen, so that's that way we can quite easily see how the DDS function generating is done. We have as a central controller an ATmega 16A with a 16 megahertz quartz, so working nearly at full frequency. It could also go up to 20 megahertz. And here we see a series of 8 pairs of resistors of 20K and 10K value, and that's a clear indication that they, this is the DAC, a so-called R2R ladder DAC, so they are using one 8-bit output port to generate the output signal with 8-bit resolution. This gives in principle around at least, let me calculate, 8 by 6 dB. This gives at least 48 dB signal to noise ratio, and already we could see it's even a little bit better. And what else do we have? An NE5532, that's a standard, I think it's a dual audio amplifier, so that's apparently the buffer here for the DDS output, and probably also for the so-called high-speed output. We have a classical ICL 7660S from Interseal, the voltage doubler or voltage inverter, so they are using this obviously for generating the negative voltage for the op-amp, so that we get a bipolar output signal. A 5-volt voltage regulator, standard 78L05, and some filter caps and diodes, and the trim port for the contrast. So not very much inside. It was nearly what I expected. Certainly an Atmel 8-bit controller, and I already would have guessed for the cheap price tag for this $20 unit, there couldn't be a professional real DAC. R2R ladder DACs are the classical cheap way to integrate digital to analog conversion. So, and that was nearly it. We have 2 pots for the amplitude 47 kilo ohms, for the offset 1 kilo ohm. Let me see if I can see if this is a logarithmic pot. No, there's nothing written on it. Of course, I couldn't measure it if it's logarithmic or linear, but from the feeling, it's probably linear. So, all in all, what is the verdict? This thing is not worth even the $20, except for one purpose. If you have one fixed frequency and you need a clean signal with less than 1% distortion, especially, of course, the sine wave with less than 1% distortion, then this is okay. But if you quickly want to change amplitude or get to low amplitudes, if you quickly want to change the frequency, or it even, why didn't they integrate a sweep function? This could all be done in software, and the ATmega 16 has enough flash ROM just to put a few lines of code inside. So I don't know why even debouncing the membrane switches. So there's a lot of things that could be improved in software and even in hardware. Change this to a logarithmic pot, and you get a much better way to set the output voltage at the lower range, at the millivolts range. There's even here one electrolytic is unpopulated. I don't know if this is on purpose or what this is gonna do. Anyway, I think I will not use this thing, however cheap it is, and I probably will use the even cheaper $7 analog XR2206 one, which should be coming in 1 or 2 weeks, and we'll see us again then here when I review this one. So this was it for today. Thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.